Okay, so now we come back from a break. So let us continue with the design and the construction of the lift system. So where we will go through the lift, the item as below. So this is the design and construction of the lift system. So typically, so this is where you are going. So the three components are motor, carrier, lift car, counterweight, as well as door system. So as you can see, the keyword here, the typical design is a car and counterweight attached to the separate ends of the roof. Okay, this is the keyword, counterweight. Why we need to have a counterweight?
The balancing, the weight of the lift, because you have to go up and down.
Without counterweight, the lift can run or not?
I think can, but then you need more energy. Maybe a lot of energy required.
More energy required. So correct. That's the reason of the counterweight. So the counterweight itself, it will balance the empty car weight as well as the 40% of the rated load. So at any point of time, when you size the motor, you only size up to 50% of the counterweight or the ratio, so that you can save energy. So this is the so-called the idea behind. So how the lift can move up? Actually, it is caused by the friction between the roof and the groove of the ship. So this is the mechanism. So this is the groove. So this is the groove. So you have the root up. So this is the friction. So this shift will be coupled to the motor. When the motor rotates, the shift rotates. So when the shift rotates, the root will follow. So if let's say the shift move, but the root will not move, then you will have a problem. So that's why I cover this traction evaluation. So main safety device, suspension groups, hoist the lift. This is the group. So the law says so, minimum 3 loops, and in Malaysia, the minimum diameter of a group must be 10 mm. Okay, and then overspeed governor, this is an overspeed governor. You regulate the speed, landing door device here. So you cannot open the landing door by force. And then buffer underneath in the event free fall, at least we have some buffer to absorb the energy. Alright. Then the braking system of the machine, this is also very important. It's an electromechanical system to release and to stop the motor. So the keyword is electromechanical. So it will cut off, it will stop the electrical supply, then after that it will engage the so-called the mechanical force supply. It could be drum brake or disc brake. For the recent motor lift, they use the disc brake. For the conventional gear motor, they use the drum brake. I think this one you have quite. I think last time you were from maintenance, you have a lot of experience with this. So nowadays, most of the system are electromechanical. We need to have electrical tripping, switching, then followed by the mechanical system. Alright. So far, okay. Lift car, so I will go through speed governor one by one. So what is actually the main criteria? What to say? The main body of the lift system. The controller is the heart of the lift system. It comprises main control unit, or we call MCU. It's a microprocessor, algorithm, so that you can program, how many floor, no distance, and so on. Inverter for VVVF drive. Transformer, of course, you need to step down some of the voltage, because for the car door motor, it uses 110 volts, so you need to have a small transformer. Switch for power supply and wiring connected to traveling cable. So this is the traveling cable. The cable are travel together with the lift car. So that you it supply the so-called voltage and current to the car fan, car button, and so on. Okay, and then guide rail is a pair of the T-shaped steel, like the like the rail to guide, and then traveling cable, car operator system. So this is a car operator system. There is a motor. When you press the button inside the lift car, the car door will open because there is a motor. And then apron is a safety feature. So this is the apron underneath the lift car to protect passenger from falling down. So and the minimum length of the apron, I think is about 1 meter, if I'm not mistaken. 1 meter. Okay. And then the governor tension sheet. This is governor tension sheet. So it will keep the tension. So that this governor rope will always tension. So whenever the lift car going down, so it will trigger the tripping. And then landing button, that one is actually for you to hit the top. Landing indicator is optional item to show or to display which floor the lift is on. So far, okay? This is the overview.
Can I ask, for the traveling cables, will you need to have replacement, or how long does it last?
Traveling cable, the lifetime, okay, usually the lifetime will be 10 to 15 years. Usually it is okay because they are not even cable. If let's say some of the cable not functioning, we can always have, there is a type of a spare cable. This is a traveling cable, is a flat cable. Inside there are many cords we can use. And then some
What is it made of?
Huh?
What is the
Material
material?
is I think a polymer and also plastic that can withstand the challenging environment. So for example, they have coaxial cable, they have some signal cable, there are also some spare cable. In case you know some of the cable not functioning, you still can change.
It must for 10 to 15 years.
This is always the design. Because this kind of cable, once you fit into the lift shaft, very difficult to replace one.
More than that. More than that.
Of course, the roof subject to the usage.
Research for apartment, normally how many years?
I think if let's say normal traffic condition, I think 5 to 6 years easily no problem. At least in the past, my experience in the seldom change major wear and tear.
5 years they change. It means that this service company got problem because every month you pay the money. But why 5 years you need to change that?
It's not because they want to change, because the condition, because there are several criteria. If let's say they have the dusty mark, stick
Because
mark.
every month they will put the oil mark.
No, cannot.
No. The roof, then they got oil and the auto something.
Actually, that is the wrong approach to apply oil onto the roof.
You will sleep.
You will sleep. Because actually, inside those group, inside the core, they actually sell lubricated already. Technically, we should not apply any oil or any chemical.
The reason typically is rusty.
Rusty have to change, no choice.
Within 5 years, the new one.
Possible. Maybe the groove of the shift is not properly maintained. Possible.
Also depend on number of leaf you have. Because if more the leaf you use, then
Every usage.
per unit
Usage.
will less unit of course. Compared 3 and 2, definitely 2 have to replace more frequent.
Environment, if let's say your
the usage, let's say we have 6 leaf. So among the 6 leaf, which one is the highest usage? Are we able to know?
Yes.
Relation to Some people even capture this information. They have to use the equipment to log in and see the usage.
So the
Do-
public
do-
cannot
you
read,
can't, you can't.
it need a special equipment to
Ah,
read.
yes. For the maintenance card, they have to use the what call.
Okay, yeah, for the maintenance guy, yes. But for the microcontroller, actually they will store also the error code also lah. They are some features like this some features like this.
So normally which one the highest usage?
Depends on the building.
No pattern lah.
But then it should be equally
Use ah.
used, but like what certain leaf because the like service leaf tie up together also some of them they want to wait for certain usage then you may not be able to use the leaf because they are moving certain item like service leaf group tie together in the same group so you will wait longer so that apparently the boundary chip will be less compared to passenger leaf. You see, this one it is actually very subjective. Then some of them they will purposely off the leaf for a certain hour, only leave a few to run to save some cost of energy. They all depend on how you
So when they change the group, they must use the compatible groups.
you see some
If let's say some big company the outsource one they don't use the compatible roof that could be a problem also.
like they leave for Opa, they want every floor to stop one. Certain leave they come I mean alternate floor. So it's all different. So alternate floor people will also use that leave and walk one by one floor. Sometimes they don't walk. All depends. A lot of things are.
A lot of things actually you see inside there are a lot of things actually. So you and all those design actually they have their purpose for example apron. So why we need to have apron let's say for example I think this one important should tell you all because this is a lift car so usually the opening I think usually is 2 meter or 2.1 meter right? 2.1 meter okay 2.1 meter. So there is an apron design is actually around
700 meter, 750
okay. So the reason why you want to cover that one is in the event the lift stuck somewhere here there is a coverage that people will fall down. So that is the reason why. That is the reason why. So that is the reason. So all this they have the safety concern. I think in the past actually very small only then at one time JKKP said no because they was considered people fall down.
Now also you have to level only in the interlocking device, the car and the landing door must be almost level only you can engage the open. So hardly that you can fall in because you need to be sort of level a little bit different of course you still can open until certain level the car both the landing door and car door the wall
So behind the scene they are engineering the logic. So limit switches is also very important. So before it hit the buffer, there are limit switches to cut out the electrical supply. Landing door partition. Okay, that one I think is cosmetic. So this is a typical lift layout plan. So this is usually for the soft drawing we have the side view and then also the plan view. So this plan view is actually being used by the contractor. They know how to install the lift. So to ensure sufficient so-called clearance. So this is the overhead, the highest floor, and then they need to ensure there is sufficient clearance top and bottom. So the purpose of having clearance is actually to protect the people, working maintenance people or installation people. So that in the case, in the event the lift overrun, the people are still protected. Not crash. So the minimum overhead can be calculated by considering lift overrun in ascending direction and counterweight buffer is compressed, then you add this one, this one, this one. That will be the overhead required. So that's why the highest the lift, the higher the overhead. then the minimum clearance at the lift measure from the bottom cross section. So this is the car frame, the lift car frame. The lowest point of the car frame to the mid floor is 610 mm. So that means the person still can sit themselves. How to say squat? Below line still can survive. So that is the reason why they want to specify all these clearance. There shall be a clearance at least 610 between the highest point of the traction machine and the hoisting hood to enable hook up the machine in case of major repair. Probably you're wondering why the dimension it has a 610.
Is it the person 1.7 meter tall lah? Then when he squat,
The law says so, minimum 610.
so maybe when he squat more than that, he has to think about how to.
Yeah, okay, the person who go into the lift, it must be a trained person. So you cannot go into the lift even alone. Anything accident happen, sorry, only those people with the trained by the lift company, they can enter the
It's
lift.
only train company, it's only train, no need to get any certificate.
For the new installation, I think they need to have a CIDD or something.
For the servicing,
Service, they have a training by the lift company.
Your record and the
Training record. Training record. So you see, most of the so-called dimension, you see 610 you know why? Because in the original JKKP Factory and Machinery Act, they use inch and feet. Yes. Feet. So that's why you see all those dimensions. So this is the lift. You see let's game.
Yeah, because it's about 2 feet only.
That is a problem already.
Now for
You have to-
5 meter, the bomba require
Asset door.
the additional access door for escape. So this is something not by JTKP but bomba on it, but still under discussion of future whether can do it. Because only one person need to working under that, and you can always climb up from this door, come out. Why you need access? Service and what you need.
But this is actually the very, very worst case. But in fact, the roof can hardly break. And then before the roof break, there is also the safety gear which already can be engaged. And this is just the very, very last measure. Still have to ensure there is a clearance, then people can lie down. So please don't misunderstand that. This one clearance is for the people who squat, because before it squat, they already have the so-called safety gear, release switches already. And then even during the lift car modernization, they also have to have a scaffolder, something like that, or framing to hold the lift already. So there are some processes taking place already. So this one is a very, very unfortunate case.
So the movie on not the correct one they asking you to squat asking you to.
It is still true in certain extent, but it's a movie.
Okay.
So this is the barricade, the yellow barricade on the lift car top. So very interesting. So discuss possible arrangement. Then I think we can discuss this.
Not saying impossible, all safety case also can fail. So, in certain times, I suppose you engage in them, but very rare because you've got so many multiple level of safety protection, you shouldn't fail logically.
So in this case, it will not be opening because when they say the rope was cut break, then it will be falling down.
You have to understand how the safety factor, because more than 4, each and every rope can hold the weight. You got 4 or 5, 6 or 10 times.
Job time. Safety factor.
Imagine you break one, you totally won't be falling.
Actually,
交大是
capacity factor, yes. So this is a traction machine, also very important. So the sizings of the traction machine, so this is a little bit of physics. So the sizings of the power is force times speed. So if let's say we consider 10% per margin, still remember just like I mentioned, the overweight 10% per margin is actually from here. So the rated load, balancing factor, gravity, speed, efficiency coefficient. So the keyword of the motor power size is here, efficiency. So its efficiency is determined by what type of the machine you are using. What type of the machine you are using. So for example, 1000 kilogram, speed 1 meter per second, balancing factor 45%, that means 55%, that means 45 that means counterweight will balance 45% of the car load plus the lift car load. Then the required minimum power is 7.0 kV, kilowatt. So, but can you really use a 7.08 kilowatt motor? Usually it's higher. In the market, there will be 5.5, 7.5, 11, 15, 17.5, 12 kilowatt. So we cannot have 准准 you cannot size exactly 准准. And then the trick is if let's say your motor is let's say you have to use 7.5 kilowatt, correct? But in the market then the inverter sizing or the inverter sizing usually we do it one size higher. That means 7.5 kilowatt motor, the inverter sizing will be 11 kilowatt. Any reason? Why? Margin, correct? Because in certain corner case, you know what I mean by certain corner case during the starting. Because when the starting, when motor about to rotate, we need to have the what? Starting torque. Starting torque. Starting torque is usually how many times of the normal torque?
This one, no.
How many times of their current consumption?
Okay, current what is the okay, torque is proportional to the current How many times?
10 times.
No 10 times. 2i No.
More than that.
Oh, I ask some.
in 3 times. I also
2 to 3 times. 2 to 3 times. But very short. Very short. But if let's say your inverter, your power, your current cannot get for that 2 to 3 times, then you have problem. Then you have problem. 2 to 3. That's why we call it what you say moment. So that's why when we look at the shift of the motor, they also have some criteria. If your rope diameter is 10 mm, your shift diameter must be at least 40 times. That needs to be 400 mm. So that is also the criteria to double that. So, but the shift diameter also cannot be too big because the bigger the shift diameter, the higher the moment. So you require higher torque. So there are many design consideration trade-off. So far, I think it's okay. So this is the traction machine installation. So this is a sound isolation pack. Like what you said, some of them they have the machine level pack, and then this one is the back breakdown. Last time I used to design this one. So this is the double rack system. So you see one side is the lift car, one side to the counterweight, and then this is the back frame, and then this is the so-called the double rack shift. Double rack shift that means the rope you rack twice. Why we have this kind of arrangement? Because it's a high speed. So when the speed is too high, the movement of the rope is simply can be faster than the shift. So we want the engagement between the shift and the rope always be intact. Otherwise, what will happen? Slip. That is also a reason behind it. So this is the roping configuration. So this is how engineer play a part with the different roping factor. So for 1-to-1, root speed is the same as the car speed. For 2-to-1, root speed is actually twice of the car speed, but it can take double load. And you still remember the mathematics, the pulley system, the pulley system. Actually, this is very fundamental. Pulley system. So there are many types of them. So usually, for the cargo lift, usually we use 2-to-1 system. Usually, we use 2.1 system. 2-to-1 rotating. So this is the rotating configuration, as you can see. So when the shift move, the root only move half of the movement. But the good thing is it can take double of the load because another load is actually taken up by here. So that means 1000 kilogram motor with the speed of 2 meters per second. So when you apply 2-to-1 looping, it can take 2000 kilogram, but the speed will be reduced to 1 meter per second. So this is usually how we play around. Okay. So 4-to-1 also good speed. Car lift. You see now this one you can hardly see. This one you can hardly see. I have seen before in Singapore, 4-to-1 car lift in last time we supply for farming, and then also mass catering in KLIA. So looping configuration. So this is something have you ever encountered about? They have a pulley on the car top. Actually, this is 2-to-1 looping. 2-to-1 looping. But that one is actually the design. So can we have the car and counterweight with different looping factor? Example, car 2-to-1 and the counterweight 1-to-1. Can or not?
Just now you all mentioned, isn't it higher road motor?
You see, if let's say now I want to play around, this one is a car. I put 1-to-1, and then another one I put 1-to-1. Can or not? Or I don't know. I say one shift I want to spend another money, and then to grab the group all the way, now I look. Can or not? It's actually very common sense.
Your diagram does not have 1-to-1 the back to just now is all either you have or.
Okay, this is 2-to-1 and when I have pulley, this is a 2-to-1 This is also 2-to-1 We have the pulley on the car and counterweight. If let's say I remove the pulley here, directly attach the root to here, with car become 1-to-1 but this one I still become 2-to-1. Can or not actually?
No, I cannot. Maybe still can. No balance.
Because one will run faster than another one.
So not balance.
So maybe what will happen is this one will run, this one will move twice distance of this one. So maybe this one move out, maybe this one already hit the buffer, so cannot. So it must be 2-to-1. Okay, 4-to-1. Okay, the answer is no, because the car will travel at half of the counterweight speed. Before car reaching the lowest point, counterweight will hit already. Okay, because we are talking about double, the half of the distance, very fast one, you can reach and hit one. Okay, module 3, design criteria. So traction evaluation. So this is friction between root and shift to drive the lift car and counterweight up and down. Insufficient traction will cause slippery, which means shift is rotating but root are not moving accordingly. Not moving accordingly. So what is the breakdown? Due to slippery? So that means sometimes when you see the lift car, they have a floor error. Have you encountered that? Floor error. That means the shift are already moved, but the root did not move accordingly. So because at the motor we have the encoder to feedback how the pulse what is the distance that shift move. By right, it should move to maybe from first floor to second floor. But due to the slippery, the root did not move accordingly, so the lift car still maintained at the first floor. So the inductor switch of the lift car still sense that it's still in the first floor, so it will cause the floor error. So can follow this one? Oh yeah, you see now? Can follow because motor, my microcontroller will get the pulse calculation computed by encoder. Because for example, it should have traveled 2 meters, but in actual case, the lift car did not travel 2 meters, maybe only 1 meter due to the slippery. So that will cause the floor error. It's very common error. So that is where you need to change the route or change the shift. Route to be So the traction evaluation, all these are the calculation. So
These are
So these are the calculation. So don't worry, just to let you know. So we need to ensure that this angle. Okay, this angle is actually provided by the supplier. So this is also the angle. So there are certain conditions. Then the tension of the root in the car is the tension of the root in the counterweight, and it has to satisfy field requirement. As you can see. So we have evaluated a certain situation. With situation, that means T1 over T2 is less than exponential of the friction factor times alpha angle. So that's why this angle is also important. So this one we call right angle. Why this right angle is important? This right angle is important because the larger the rapid angle, the more contact surface between the groove and the groove zone. Correct? So minimally, I think it's around 145 to 160 degree. Okay. Then we have also evaluate different corner cases when the lift car is at 125% of the rated load at the lowest floor, and then on the empty car at the highest floor. Why? Just now I talked about 10%, but the traction evaluation I talked about 125%. The reason is just to give more allowance or margin, from the engineering standpoint. Then during the safety gear operation, okay, when the car is at the lowest floor, also cannot spin. What will happen if let's say safety gear engaged car slip, what will happen? That means the rope will still run. So it will cause the loop stacking. So this is also dangerous. But in one circumstances, we want root slippage, whereby lift car stop and the counterweight already hit the buffer, resting on the buffer, and traction lift machine still moving. At that time, we want slippage because we don't want to have further movement. I can follow. So that's why a bit complicated. That is the reason why we certain situation we want it to be non-slippage, for certain condition we want it to slippage. Okay. So this is the case 1, case 2, case 3, and case 4. So this one lift car you already sit on the buffer. You want it to slip. The motors can still run, but the lift car cannot move anymore. Why? We just in this case only. This one already sit on the buffer. Chonky, quick kicking. That time we want it to slip. Can follow escape. Air. Follow Okay. So that's what we talk about We don't want it to slip now, but the motor shift still continue running more. How? So we have the motor runtime limiter. So traction lift shall have a motor runtime limiter causing de-energizing the machine and keep it de-energized. If the counter weight is caught at the downward movement by obstructor cause the lift to slip, then after certain time, 45 seconds, or the time for traveling in the full travel plus 10 seconds. That means that if for error now, signal occur maximum 45 seconds, it will cut off the supply. So it keeps the people in the lift car safe. Okay, you follow? And okay, lift car design to ensure lift car is to accommodate. So this one is a lift car construction. This one double deck. Double deck, no? This one is the double deck. Then this is the lift car design. Then this is the lift car area. So so for the lift car area actually also defined by this table. By this table from TTT, only from the factory engineering. But I think for IATAN, the consultant usually they will refer to the lift manufacturer. Catalog, we refer to the catalog. So different requirement for passenger lift and boost lift. This is what I mentioned just now. Conversion of boost lift to passenger lift or vice versa is not straightforward because the floor area is different. Floor area is different. Okay, so far can follow. Okay, so this is the best duty table. This one is mainly from the catalog. So this one the car interior design. So I think nowadays more and more design are with this kind of display. They put in some what we call advertisement or whatever. So this is a door system. So there is a center opening or side opening dedicated for the different usage. But for example, hospital usually they like to use side opening. Actually, for the side opening, the door opening time I think is longer. So this is the center opening. So the motor will engage and then the door open together. Whereas side opening, it open like this. So it will take longer time. Now for the same opening, so this is the side opening. So this is the lift safety gear. So there are two types of safety gear. So this one I think I can also explain. So one is actually instantaneous type, another one is not instantaneous. Instantaneous means immediately the lift will stop. But in our application, we have to use non-instantaneous. You know any reason why we need to use non-instantaneous? Not to break immediately. Because so when non-instantaneous there will be the sliding distance. So it's actually to reduce the impact to our body. Understand?
With the autonomy.
With the shock come our body, our back cannot take one. So that is the reason now. So this is the gripping trace. So this is the gripping trace. After the safety gate engagement, so they have to polish the guide rail again and then lubricate again. So some of the photo so this is the dorsal, sliding gear, stick governor. This is the real buffer, VD switches, braking system. This brake. If let's say you have time to go to the motor room, some of the photo. Rope and cables. Okay, so this one I think important. So construction of the rope. So now this is the coil. There are wire. This is the string, and then after that they have another string. So this is typical construction.
So how many percent they will consider this table?
Huh?
How many percent? How to consider this?
We will go through together. There are certain criteria. So you see, for this group, the construction we call as a right hand brake. You can see. Right hand brake. For the good course, left hand brake. So group manufacturer certificate, I think this is always we have to refer furlong. So the law says so, the groups for the one machine must have the same characteristic. That means you cannot have one group from Tokyo Road, another group from another manufacturer, cannot. So the best is all the group are from same drum. Same drum. Because then you can guarantee the same characteristic of the beam. I think consistent. Why we want to have it from same drum? Because we want to ensure that they have equal tension strength. You see, breaking strength. So this is the visual inspection. Broken wire, bird caging, corrosion, heat damage. Okay, so this kind of the common damage must stop operation and replace loop. Cannot be compromised. Although we say that minimum 3 loop, the loop will not be simply break, but cannot be compromised at all. So this is the diameter measurement. So if the measured diameter reduction is 10% of its nominal diameter, we also have to replace. Okay, if we can argue, okay less than 10%. So what? The breaking extent, if let's say I can check the tensile strength, essentially the tool to check the tensile strength still okay. Why I want to change? This argument is strong, no? If I want to save money, say I don't want to spend money, although already reduced 10%, I ask engineer to check the tensile strength still same. I don't want to change, can or not? Why? That is still remember just now what? You still remember just now what I have mentioned? You will not have artificial friction. Then we do have artificial friction, loops break. So this is the technical argument. Okay, I borrow. So this is a suspension loop. So Malaysia minimum 10 Nm. So suspension loop safety factor 12 times. So how we calculate? Very simple, number of loop times grouping factor times breaking strength of the loop divided by full car weight. Full car weight. So this is safety factor. So compensating chain. Compensating chain is a chain installed from the counter to lift car to balance the weight of the group. So see that if let's say the travel is too high, the length of the group is significant. So the weight of the group also significant already. So we use the chain to compensate the weight. So that the motor still the motor will not be overloaded because they need to take extra load already. So this is the reason behind. Okay. So this is the design. So our electrical system, I think is not. See that. Steering cable, EVA, EVC material. Then this is the simple electrical system. We had the incoming 3-phase circuit breaker. Then this is the elevator machine system. We have some power outlet, so that maintenance guy can plug in some tools, and then the supervisory room. Okay, this is the heat outlet, so that sometimes they can put in the vacuum. So the minimum size of the ground wire determines according to ampere rating of the circuit breaker installed at the power source side. So I think this is quite technical. But just to let you know, electrical system is very small portion of the lift system. I agree on. Very small portion only. Basically, it's just a cable go up to the motor room, traveling cable. The rest are mechanical. So this is the traveling cable. Traveling cable actually it did not hang from the top one. It will hang half of the lift shaft then the lift car only carry the weight of the half only. That is also engineering. Yeah.
Then how does he move up?
Ah, yeah. This one, this one the lift. Okay, let's say the lift. I put in the center Put in the center This is a carrying cable. Carrying cable usually will fix. I think half of the lift shaft only. Then the half will be like this. Because no matter how we run, here will be the fixed one. Otherwise, this carrying cable will be hanging. So this is how we fix it. Interesting. Okay, module 4. Okay, I think we can take a break. Okay, let's go.